Hello, welcome back. We're going to talk about a different kind of multi-step equation. So, same steps as before, we're still going to distribute, meaning if we have a set of parentheses, we're going to distribute that outside number by everything that's inside. We are still going to combine like terms, meaning if we have terms that have x's, we're going to add those together. Or if we have terms that are constants, we can add those together as well. And then we're also going to isolate the variable, aka get an x by itself and seeing what it's equal to. Same steps are still going to apply here, only this time, when we look at this example, you can already see it looks a little bit different. I see that I have x's on both sides of my equation this time. So let's go through our steps and kind of see what we do about that. So again, that first step is going to be distributing. I see that I have parentheses over here. So I'm going to take this 4 and multiply it by everything that's inside of those parentheses. Remember, if you don't see a number next to your variable, that's just going to be a 1. So when I multiply these, I'm going to do 4 times 1x, which is going to be 4x. And then I'm going to do 4 times positive 3, which is going to be 12. And then I'm going to copy down the other side because I have not touched it yet. I am just distributing what is inside, or sorry, what's on the outside of those parentheses to everything inside. Okay, my next step is going to be combining like terms. So again, I'm looking for doubles here. I'm looking for x's in particular that I could add together. But before, all of my x's were on the same side of the equation, so I just took whatever sign it told me, and I used that to combine. But this time, my x's are on opposite sides of the equation, so I'm going to have to use opposite operations to move them over. I see that this x is positive, so I'm going to do the opposite and use a negative to move it to the other side. But really important here, if I have an x, I have to take it away from the other x. I cannot take it away from the 12. That's not going to work. You can only take x's from x's and constants from constants. So what I'm going to end up with here, I'm going to have my x's on this right side go away because I just subtracted an x from an x and I got 0. And now I have 4 minus x. Again, if you don't see a number in front of your variable, just put a 1 in there. I have 4 minus 1. That's going to give me 3x. All of the other pieces that I have not used yet are all going to come down into my new problem. So I've combined my like terms. I've combined my x's together. So now I'm going to go with step number 3, which is isolating the variable. So my variable is going to be my x over here. I want that to stay. I'm going to go in order to get rid of this 3 and this 12 because those are both on the same side as my x. Whenever I do these, I'm going to add or subtract first. So I see I have a plus 12 here. So I'm going to subtract 12 so that I can get a 0 here. 12 minus 12 is going to give me a 0. So I'm going to be left with 3x equals 36 minus 12. That's going to be 24. I still need to get this x by itself, though, so I got one more step to do. I see that my 3 is right next to my x, so that means that they're being multiplied together. So the opposite of multiplication is going to be division. So I'm going to divide by 3 on both sides. So that when I do that, my 3 divided by 3, that's going to give me a 1. So I'm going to be left with x equals 24 divided by 3. That is going to be 8. And that will be my answer for this question. So again, we still went through the same steps. We distributed, we combined like terms, and we isolated the variable. But this step here looks a little bit different than usual. If your x's are on the same side, use the same sign. But if your x's are on opposite sides, use the opposite operation to move them together. That's kind of the best way that I like to think about it. Let's try one more. Let's do number 1. So number 1 says that we have negative 3x plus 1 equals 2x minus 9. Okay, I'm going through my steps again. My first one was distribute, but I don't see any parentheses here, so I'm not going to do that step. I can't distribute anything if there's no parentheses. So I'm going to move on to step number 2, combine like terms. I see that I have x's on both sides again. Since they're on opposite sides, I'm going to do the opposite to move it over. I'm going to take this 2x. I have a positive 2x, so I'm going to say minus 2x. When I subtract those from each other, I'm going to end up with 0. But whatever I do to one side, I'm going to have to do to the other as well. So now I have negative 3 minus 2. That's going to give me negative 5x. I haven't used that plus 1 yet, so I'm going to bring that down. But I do have a minus 9, so I'm going to keep that. Cool. All right. That was step number 2, combining like terms. Now I'm going to do step number 3, which is isolating my variable. I want to get this x by itself. Again, there is an order here. So I'm going to try and do my adding and subtracting first. I see that 1 is being added on to my x. So I'm going to use my opposite operation, and I'm going to subtract 1 from both sides of my equation. 1 minus 1 is going to give me a 0. So those are gone. I'll be left with negative 5x equals negative 9 minus 1. That's going to give a negative 10. Okay. Now I got one more step to do to get this x by itself. I see that I have my negative 5 still. It's being multiplied by x because these two are so close together. So I'm going to divide, which is the opposite of multiplication. When I do that, negative 5 divided by negative 5, that's going to leave me with a 1 or just an x. And then I have a negative 10 divided by negative 5. That'll give me a positive 2 for my answer. And now I know I'm done because I have that x by itself and it equals my number. That's what we got for multi-step equations with x's on both sides of the equal sign.